Good day. My name is Berkenda. I'm the Director of Operations and Strategic Projects here at OmniAir Consortium. Before we get started, I just have one quick reminder. I would love for you guys to ask any questions. You guys have access to the chat. You also have access to the Q&A box. Either works for me, so go ahead and type any questions as they come up. However, we will answer them in the Q&A portion, which is nearer to the end. So don't think we're ignoring you. We're just going to answer them all in one segment. I do see quite a few familiar faces, or faces flow. I see familiar names here in this chat from Salem, Oregon. We've got Montreal, lots of Anaheim, of course. We see Ryan in Anaheim, California. We know where you live, Ryan. But so many of you guys are so familiar. We thank you for joining us today and can't wait to get started. So, for those of you who don't know, OmniAir is the leading industry association promoting interoperability and certification for connected vehicles, ITS, and transportation payment systems. Our members include connected vehicle, intelligent transportation systems, and road tolling technology device manufacturers, ITS deployers, test laboratories, and other stakeholders, all promoting the proliferation of certified interoperable devices. For nearly a decade, we have provided the opportunity for members to work collaboratively to develop and determine the requirements for national certification programs. Our nearly 100 members have the opportunity to shape the future of ITS and IoT technologies and to work with industry leaders and transportation professionals to accelerate their interoperability. Building on our certification programs for RFID tolling, DSRC, and CBDX, OmniAir has launched an initiative to explore certification needs and to develop new programs to address new payment options for transportation, including B2X-based tolling and road usage charging, also known as RUC. Today, we are pleased to have with us two of the leading experts on RUC, who are also members and who are helping drive this initiative forward. Maureen, if you can go ahead and pop on the screen. It is my pleasure to introduce today's first presenter, Maureen Bock. First, Maureen is Oregon DOT's Chief Innovation Officer, where she oversees Oregon's Road Usage Charge Program, ORIGO. Maureen has an undergraduate degree in accounting from California State University, Fullerton, and her Juris Doctor from the University of Arkansas. Maureen's passion is developing new programs based on innovative policies and her background in operations. Maureen was formerly the ODOT Fuels Tax Manager, where she began to automate the manual methods of collecting millions of dollars in fuels tax revenue. The system is in place today and enhances compliance and administrative capacity. Maureen left ODOT in 2011 to work for the Oregon Department of Energy, where she redesigned its tax credit programs. She returned to ODOT in 2014 to become the Road Usage Charge Business Implementation Manager. In that role, she used her background in fuels tax and tax administration as she worked with a team of business and IT professionals, as well as commercial vendors, to design and implement the nation's first road usage charge system. The system is the first to validate mileage and fuel consumption and to calculate and collect taxes according to state policies and statutes. She continues to lead the evolution of ORIGO program in order to make it a more sustainable, agile, and resilient funding mechanism. Maureen, we are so happy to have you here today. Thank you so much for joining us.
It is very good to be here. Thank you for including me in this. I'm going to start with an overview of what took us to this place where we were developing this new funding system, discuss a little bit about the similarities that the road usage charge program has with tolling. So this is just a miscellaneous approach to giving you some background information. Next slide. So in the early days, governments really struggled to regulate that transition from horses and buggies to more modern transportation modes. Cars required better roads, bicycles needed to be accommodated, and in Oregon, as you probably know, it rains a lot. So in 1919, the legislature adopted a gas tax, first one in the nation, and they sold it to the Oregonians as a way to get Oregon out of the mud. It was very successful, and then they have changed in their funding mechanism in response to changes in technology. And you see some of the challenges that we're looking at, how we're going to accommodate in the future, how are we going to leverage AI machine learning, what are we going to do with our ITS system, how are we going to accommodate digital plates, et cetera, et cetera, et cetera. So as we change our technologies in transportation, we are going to be looking at new ways to fund transportation as well. The next slide shows a roadmap of how we actually started funding transportation, some of the changes along the way. Like I said, in 1919, Oregon introduced the first state fuel tax, which was based on gasoline. And then 13 years later, the federal government did. Along the way, other states adopted it as well. In the 1930s, Oregon was one of the first states to start requiring biennial highway cost allocation studies. And then when trucks came online and were using more diesel, Oregon levied the first weight mile tax on heavy vehicles. And then in 2015, we launched the first road usage charge program in the country. And now at least 13 states have introduced legislation, and in the next legislative session in 2023, there are at least 5 states that are thinking about making road usage charge a mandatory program for some subset of passenger vehicles. So it's a long and winding road, but it's very important that we have good roads in the short term and potentially the long term until we all are flying around in air taxis. The next slide shows what we talk about when we are talking about road user fees, and the distance tax, what we call road usage charging, is but one of them. So we have a weight mile tax for trucks, we have a fuel tax for all vehicles that aren't in the RUC program. We're instituting tolling on both roads and bridges. And we have some transit fares and HOV lanes as well. So these are the kinds of things that we consider road user fees. And so we want to make sure that that umbrella term is used in an appropriate manner for things like our highway plan and those kinds of things. But what we're really talking about the distance tax and road usage charge program doing is substituting for fuel tax, where people pay one or the other. And the next slide shows that fuel tax is really unsustainable as vehicles become more efficient. There are other reasons, but if you go to the next slide after, this one shows that fuel tax is unsustainable. The next one shows why it's unsustainable. We are being hit with inflation just like everyone else is. So materials cost more to do, build roads, maintain roads. And the increased fuel efficiency of the light duty fleet is really causing concerns with long-term viability of fuel tax as a funding model. And then in our state, we've had more people move in, and even during COVID, when people weren't necessarily driving to the office, we saw an increase in vehicle miles traveled based on the fact that people were ordering goods to be delivered to their home. So we have more people, we have more VMT, more wear and tear on our infrastructure. So the next slide actually shows the impact of increased fuel efficiency. So all of these vehicles weigh about the same, they do about the same amount of road damage. But as you can see, electric car in a fuel tax model pays nothing for the wear and tear it puts on infrastructure, and a pickup is paying substantially more. So in an effort to level that, because we want to be equitable, the next slide shows what the impact is if these vehicles are all in a road usage charge program. Now in our state, the low efficiency vehicle, which we define as something under 20 miles per gallon, is not actually eligible to be in the program because we feel that it's paying its fair share if it stays in the fuel tax program. So that's what we're trying to do, is we're trying to make the payments equitable, which is in accordance with our highway cost allocation study, and it's also just a big tax fairness issue. So the next slide actually shows that there are 3 states that have mandatory programs, although they're all voluntary at this point: Oregon, Utah, and Virginia. Other states have considered passing a program. Some states have actually studied and participated in pilots. You can see those reflected as well. And like I said, in 2023, there are at least 5 states that are going to be considering legislation that would make the program mandatory, and not just in a voluntary way, but mandatory for at least some subset of passenger vehicles. The next slide shows how it operates today, which is a motorist signs up with an account manager. The account manager provides the device that goes in onboard diagnostic for the vehicle or sets up a manual account for them. All the payments go to the account manager, who then actually files a quarterly tax report with us and then pays us for all miles driven. So that's what we have right now in place. We, of course, would like to change that and make it where the information is coming directly from the vehicle itself and not through a device that has to be installed in the vehicle. So when we set up the program, we knew that certification was going to be really important. And so if you look at the next slide, what we're doing currently is we are certifying all the processes of an account manager in-house in what I call an artisanal way. So we have requirements, and we ask our business partners to certify there's components of their solution. And we test those against our requirements, and then we do end-to-end testing to make sure that everything works as intended. So Ken, if you can go the next couple of slides. This is an example of our requirements, and these are foundational for our current certification requirements. So we look at how the vendor proposes using their solution to meet our requirements. When we set the program up, we actually divided North America into geofence regions that correspond to all the states and provinces. And this ended up creating a way to facilitate interoperability between states, but also to exclude from the person's bill miles traveled outside of the state of Oregon. We also created additional ways to geofence locations. And so the next slide shows how we created sub-rule IDs, which were just identifiers for political subdivisions such as cities and counties. And this was to accommodate things like a local option road usage charge, because we have a local option fuel tax in the state of Oregon. And then also we had a zone rule ID, and those could be for even smaller areas. So we could do local option RUC, congestion pricing, or tolling with the same solution. We tested that in a program we completed a year ago. And the next slide shows how we did that. We looked at 3 geofenced areas. We did variable pricing by time of day, and we layered this on top of the state rate. So this pilot actually involved 75 people in each one of these that had never been exposed to a road usage charge program. They were selected based on the demographics of the area itself. And then we had people drive and interact with our research provider, who gave them a series of questions to respond to over the course of the driving, which went on for 6 months. And what we found when we did that is reflected on the next slide. People really wanted more information about Orgo. They also wanted more information. Go back one, please. They wanted more information. Now back to the one that says key findings. Back one more. So people really were intrigued by it. Some people actually wanted to know why this wasn't already in place. And we found that much of the travel that was done by single occupancy vehicles was pretty inflexible due to people's work or their childcare arrangements. So we thought that there would be little impact on travel behavior based on variable pricing. So this information is being shared with our partners in the Portland metro area as we embark on tolling. So we want to make sure that people can get away from having 2 devices like a toll tag and an onboard diagnostic port device for those kinds of things. The next slide actually does show how we've thought about the world in our open architecture was actually required by our statute. So data collection occurs from the vehicle itself. It may or may not go to the same entity for transaction processing, and then it may or may not go to the same entity for account management services. So these are all modular. And Frederic will get into more detail in his presentation, but it makes standardization really important. And it also lessens the burden for ongoing support and maintenance by having an open architecture. We've also been examining the commonality between RUC and tolls. So the next slide shows how we've aggregated those same things and done comparison in data collection, like in tolling, there's roadside equipment. There's not in RUC, for example. Transaction processing may occur at the roadside in tolling, or it may occur in the vehicle like it does for RUC. But there are very much similarities at the data elements that are collected and how they're processed. Some of the efforts that we have going on in the state of Oregon to facilitate this involve development of a connected vehicle ecosystem. The next slide shows at a very high level how we envision that working. So we see that there'll be some IoT or edge computing with connected devices, systems, and facilities. And then we'll have cloud analytics that will help with data processing and that kind of thing. And we anticipate developing an open ecosystem that can evolve to support both our ITS functions and to deliver RUC services. So the next slide actually shows what the objectives are. The next one shows the objectives for the CDE project. We're partnering with industry on the V2X and cellular connectivity. We're looking primarily at safety and mobility for being use cases that will be enabled by this. And then we're going to do a pilot on our use of charging to see what the gaps are so we can prepare for mandate. So really, we're looking for a partner that will establish a long-term business relationship with us and help us develop a business model for this going forward. Because at the end of the day, we really want to be using OEM applications instead of aftermarket devices. So the last slide is really shows how we next one for Kindle. The road usage charge program action. Oh, I forgot to put this one in here. This is how we actually envision the ecosystem working. So we'll be using direct communication with our signals, doing signal phasing, that kind of thing. Also looking for ways to protect vulnerable road users on our infrastructure. And then also having vehicle to vehicle or vehicle to network capabilities with the CDE. Next slide. So really at the end of the day, we're really looking at our road usage charge program as being a return to the user pays principles, consistent with our highway cost allocation study principles. So if you drive more, you pay more because you're doing more damage to their infrastructure. If you drive less, you pay less for the same reason. And that's it.
Thank you so much, Maureen. We so appreciate that. Very in-depth, very informative. Frederic, if you're able to pop on, I will give your introduction. Also allow you some screen sharing. 1 second.
Hello, everyone.
So Frederic, while I'm doing your bio, if you want to go ahead and get your presentation up, that'd be great. So, founder and CEO of ClearRoad Inc. ClearRoad is a startup company helping governments to monetize road usage vehicle data. Frederic is a transportation expert with 10 years experience in the conception, implementation, and operation of groundbreaking projects. He worked for several tolling firms such as Sanef, Bip & Go, and Imovis. Frederic has been a road usage charging pioneer since 2014, deploying the first Oregon account manager system. Frederic, welcome, and the floor is yours.
Thanks, Bekenda. Can you hear me all right? Everything's good? Cool.
Yep, you're good.
Okay, so after Maureen's presentation, which really went in depth about all aspects of road user charging, from policies to certain decisions in terms of technology. I'm just going to focus on different approaches of RUC and the implementation challenge. So I think that when I start talking about this, I always like to use this image of the maze that is needed once we started doing road user charging to get to the perfect implementation. So it's not to discourage anyone to participate in RUC program, but more to acknowledge that there are different approaches, there are different challenges, and it's not a straightforward conversation. And based on this experience, I think we have made, based on the experience of the last few years, we've made a lot of progress. And so I think we are getting very close to the perfect road usage charging program. So let's talk about a few of the challenges. So starting with the RUC architecture. So this is a diagram of the RUC architecture. And so what I'm going to do in the next 45 minutes is I'm going to go after every and each box of this diagram and explaining all the information related to that. Obviously, I'm not going to do that, but I'm going to help you understand it, even for people that have less experience with RUC, how it is structured, and it's not that complicated. So this is the official, one of, maybe not the latest, but one of the most used diagram to represent a RUC system. And so it's actually divided in very clear roles and responsibilities. So there's the owner of the vehicle. There's the data collector or mileage reporting option. So how do we get data from the car to actually price road usage charging? The account management component, which focus on taking that data and making sure that we charge the right amount of road usage charging to the different drivers. And then the administrative system. So I just want to make sure that you see my screen. Yeah, so if we go one step further and try to discuss the duties and roles of each of the stakeholders of this ecosystem. So as I said, the account manager, which as you see, collect the revenue from the driver on behalf of the different government entities. So the account manager manage a great number of customer accounts. Each customer account corresponds to a driver or a fleet of vehicle. Then you have the data collector, which usually only focus on collecting data from the cars and trying to manage the challenge of having potentially different types of vehicles on the road and being able to support all of them with a mix of technology. And we'll get into a bit more details on that. And then the owner of the vehicle, which use the road, so has the service of, has the opportunity to use this magnificent infrastructure that enables him to move from one place to another. And in exchange to that service, he pays for the usage. So obviously he has paid part of it through the tax, but here we're talking about the direct relationship between the amount of road that is using and damaging and the amount that he has to pay for it. And then the government entities that are in charge to manage those programs. So it means, you know, not only manage the flow of revenue coming from the users through the account managers and then to the government, but also ensuring that the overall program is working well. So it's setting up the technical requirements, define the policies, and so on and so forth. So, you know, coming from the tolling industry and talking to a lot of tolling folks, there's a big question about why do we need an open architecture? Because an open architecture means that you can have multiple data collector, multiple mileage reporting technologies, as well as multiple account managers. So why do you need multiple vendors to collect from the taxpayer? when in a toll program, usually you just do one RFP and select one vendor. Sometimes you have multiple vendors, but each of those vendors has some sort of monopoly on a certain part of the system. So the reason we have open architecture in the RUC space is because there are a few ways to explain it and show that it makes sense here and maybe make slightly less sense for tolls. So first is that the mileage reporting technologies are tied to vehicles, not tied to the infrastructure. So the idea here is if you have one technology that works in one vehicle and that vehicle travel around the country, you need one operator to manage that vehicle. But you can have in parallel multiple vehicles driving on those roads using multiple technology being operated by multiple vendors, and that does not really necessarily add complexity to your system. So the second point is, as I said, this vehicle can drive everywhere, and the tracking technology will continue track those miles across all these different jurisdictions. So there's not so much as in the tolling industry, really a geographic aspect of it, because as soon as you track miles, you can. There's no really limit. So the challenge in the RUC space is how do you, from one vehicle, make sure that the information gets to multiple jurisdictions potentially. And then one of the advantages of the RUC space compared to the tolling industry is it's much lighter in terms of roadside equipment, because roadside equipment in the tolling in the RUC space is not used normally for pricing. It's potentially a tool for enforcement, like maybe you need some cameras on the road just to make sure that everyone that's supposed to pay RUC is paying RUC, but you don't use those cameras to try to generate a pricing toll transaction like you do in tolling. So you don't have the same, so that's where we can have a good analogy between the difference between utilities where you have a strong equipment on the network to be able to operate, and so usually it's more efficient to have only one vendor that's a monopoly geographically. When in the case of RUC, it's a little bit more similar to telecom companies where you have multiple networks operating in the same location and offering multiple options to drivers. So that's like at a very high level why RUC is more inclined to have an open architecture compared to the tolling industry. So now let's go slightly deeper into that aspects of open architecture. So first, what are the benefits of having an open architecture? So in the benefits, you have obviously competition. If you have competition, if you have multiple vendors, they are obliged to provide a good service if they want to stay in business. When in a closed system, once you choose one vendor, hopefully he's doing a good job, but if it doesn't, it's very difficult to find an alternative. It's also, and that's very important on the political side, to enable a user acceptance. And again, people having choice makes it easier for them to say, oh, okay, it's not like something that's imposed to me. So it's making like more unpopular, but saying, okay, there is this rule, but I have different ways to go about it. I can choose between different vendors, so I can potentially choose a technology that works better for me or something like that. And so that we have seen is very important for user acceptance. And then in the same vein than competition, if vendors want to increase their market share, they have to find ways to attract them with potentially value-added services and specific revenue models. So it kind of gives like more opportunity to innovate and to try new things when you have multiple vendors in the market. Then obviously everything comes with a price. So what are the barriers? It's slightly more unusual for procurement, and I think Maureen can speak about that at some point, but convincing the procurement department that you have to do an RFP that will work for multiple vendors, and that this RFP is not tied for a specific window, but can be recurrent over a long period of time has been, I think, quite a challenge, just because it's unusual. So that's one barrier, obviously. Then there is questions about the revenue collection efficiency. So having multiple vendors is great, but if revenue collection becomes inefficient because it's like you have too many vendors operating that you have to manage, that you have to certify, compared to the amount of revenue that you're raising, it can be less efficient than one vendor that provide the overall solution. So obviously there are ways to solve that problem, maybe with a centralized hub or a clearinghouse. And in the same vein, managing of the ecosystem, when you have multiple vendors, it's more complicated to manage them than if you have one vendor. If it's obviously, if it's a good vendor. So it's a, you know, it's another big bargain, basically. And again, there are solutions because each state is, if multiple states are running the same RUC program, potentially they can work together to do one process that would now allow vendors to be available in multiple locations, which reduce the complexity of managing the ecosystem. So all these barriers have solutions, and you know, Oregon and other states have already explored ways to improve that. So now, what could an open RUC architecture look like? So here is a quick demonstration of what it would look like if you have a lot of players. And so compared to the first diagram, there is a potential to add a regional clearinghouse to kind of streamline some of the exchanges between the different vendors. And this is something I think Oregon has been thinking about. So let's talk about challenge number 2, mileage reporting option. So a lot, when we talk about RUC, and since I've been in the industry, everyone has always been very curious about like the different technologies that are available to collect mileage. It's kind of exciting. And so over the years, we have seen multiple technologies. We have tried multiple technologies with, you know, good and bad. And so that's what we're going to do now, is going over all these different options. I think I cover all of them, but maybe there's a new technology that I'm not aware. And so please, if you want to add something, or don't hesitate to send a message on the chat. So as I said earlier, I'm just going to repeat just in case. So the big difference between connected vehicle and electronic toll collection today is, one is really focusing on the vehicle, so getting the data from the vehicle. When in the electronic tolling industry, the data is coming from the infrastructure. Even though if the infrastructure talks to the car through talking to RFID or take a picture of the license plate, it's still very infrastructure centric. In RUC, we're using vehicle as the source of data, and we can use roadside equipment more as an enforcement mechanism. So the first technology is the OBD2 device. So this technology has been like the first, maybe not the first technology used, tested for RUC, but the first to be used in a real world program. So when we started Oregon in 2015, that was the only technology available. This technology has many advantages. The first one is it's compatible with most vehicles on the road. When I say most vehicles on the road, but maybe around 95 to 98% of the vehicles on the road. So it's like a universal solution. And in addition to that, it gives a lot of data, and so a lot of flexibility to do RUC. So just for those who don't know, so it's a small device that you're going to plug below the steering wheel in the OBD2 port that's usually used for diagnostic purposes. And so it's pretty simple. So we, you know, fleets usually have someone to install them, but regular drivers can also install it. There's no complication to that. The only drawback is you have to buy that device, and so if the car doesn't have it, you have to finance buying those devices, and they are much more expensive than a toll tag. And there's an operating cost associated with it because you have to send that data over the cellular network or LoRa network, and so that has a monthly cost on top of that. Then you have commercial fleet telematics devices. Some use variation of the OBD2 device. Some use other protocols or other technology, but it's the same approach. Is you have a device that you're going to add onto the vehicle, aftermarket device that's going to enable you to track the vehicle, and also not only where they drive, but also information about the what's happening in the engine and stuff like that. So the advantage obviously here is most fleets have those technology already installed for the purpose of managing the fleet. And so it makes it potentially more easy to build RUC on top of it. The only challenge with that is you have to deal with multiple vendors. And so you can face a complex ecosystem issue of trying to connect 20 vendors that all collect similar data, but have to provide it to a centralized system. Then there are, we're not only about like very high technology, there are approaches that are slightly low tech. So one of them is the odometer capture. So it's this idea that, as everyone has a cell phone in his pocket, it's very easy to take a picture of the odometer once in a while. And with that, comparing photographs, you can know how much mileage has been done on the vehicle. So obviously the costs and the barrier to entry are very low. It does require involvement from the driver on a regular basis. So it is slightly more demanding from the drivers to take pictures. We have done pilots where they had to take pictures once a month and once every 3 months. So what happens if they don't? So there's slightly more management to do about the customer and potential opportunity for error. Obviously, it's also very limiting in terms of the data that you collect. So you can only do very basic RUC approaches. So charging per mile for all miles with the same pricing will work. But if you want to go into more complex RUC system where you have the geographic element taken into account, then it won't work. And so far, I'm not 100% sure, but this technology has had a very limited use as a primary technology to collect mileage, but has been much more used for a secondary technology. So you have maybe OBD2 as a primary source of data, but you want to do checkups once in a while, and so you use odometer capture. Sometimes even those odometer capture does not require a picture. It's just the driver indicating the amount of mileage that they have been doing, and you trust is reporting. Slightly more sophisticated using the smartphone, again, is this idea that, you can, as most smartphones have GPS embedded, why don't you use GPS from the phone to collect mileage? And, we all have used Google Map of Waze, tracking of where you drive through those apps work really well. The only challenge with that is the phone is attached to a person, not a vehicle. So you can have some impacts about like how are you ensuring that mileage is always captured, and you can assign a vehicle to it. And then there's many edge cases also around what happened if the smartphone ran out of battery and things like that. So even though it sounds really attractive and the data that you collect from that technology is good, there are a lot of edge cases that you have to work around. And so in a road usage charge program where you need collection of mileage at all time, that can be tricky, at least as the main technology. Could be helpful for certain segments of users or certain segments of edge of cases, but as the primary technology to potentially replace odometer or to replace OBD2 devices can be challenging. Obviously, that's only my opinion from my experience, but I think it's also the opinion of a lot of people in the industry. Then there's maybe one of the most exciting technologies in the road charging space is to think about how can we leverage embedded telematics. So telematics technology that's already embedded into the vehicle. It's also called OEM telematics or native OEM telematics. There's different names. The idea is most recent cars have some sort of telematics embedded into the vehicle. Why don't we get the data from that, from the vehicle itself, without having to add an additional device? It has a lot of advantages. You don't have any doubt about to know where the data is coming from, because you know from the OEM that the data is coming from that vehicle and not another vehicle. So it does not require any installation from the driver. It's growing. The numbers of vehicles that you can access is growing. There are standards where you can get that data from the OEM pretty easily, maybe cheaper even than OBD2 devices. The OEM trying to find their business model in that industry. So sometimes they also potentially don't exactly understand the price of that data. And so we have seen application where they charge more than OBD2 devices. And so this is still an ongoing negotiation about what is the right pricing, but potentially that can bring the cost of collection of road charging at a much lower level if we leverage strong agreement with OEM. It's obviously something also that ODOT is exploring with the connected vehicle ecosystem project. And then the last thing that I want to mention on this is the fact that vehicles, make and models, don't always have the same capabilities. So sometimes, like the first into the market with a GM vehicle using OnStar system, they have connectivity for vehicles since 97. The problem is that the technology they embed in the car at that time, it goes through 3G, maybe not more, and so the frequency of data that you get from those vehicles is absolutely not the same that the ones that you get from a new Tesla 2022. And so, as a RUC operator, you have to deal with different frequency of data, different quality of data, but at the end still deliver the same service to the driver or to the government. And so this is maybe one of the biggest challenges with OEM data, is how do you standardize, how do you make sure that you have like comparable KPIs between the different make and models, and that you don't have to go into too much detail with the users about like the differences specifically to their vehicle compared to the average vehicle in the market. So to summarize, the OBD2 device is the most robust solution today. The fleet telematics, the low-hanging fruit, because all these vehicles have already the technology installed. Mobile-based technologies are the cheapest option, and the OEM telematics is the best bet for the future. But as you can see from my explanation, and again, maybe other people will have other opinions, but I think most people will agree with me, is that there is not yet a solution fits all for road charging. We have still to think about solutions that can have multiple technologies to being able to support all vehicles driving in a specific state, and at the same time trying to get the best and the lower cost as possible. And in that front, there's no obligation. I mean, in the toll industry, we tend to want to use even what I've seen is like, even now it's changing, but in the past you only have one protocol, one type that were allowed into a network. In roadside charging, there is no obligation to have one mileage reporting option only, and that's, you know, aligned with this idea of open architecture, where you can have multiple vendors, multiple mileage reporting options operating at the same time. And those technologies will also depend on the decision that is made at the policy level. So what type of pricing do you want to do? Is it complex? Is it simple? And what segments of vehicle are you targeting? Are you targeting only new vehicles, or you want to cover all vehicles registered in the state? The timeline, and what is the cost that you are willing to pay for collecting the revenue? Obviously, if you want to collect $20 a year, it's going to be difficult to justify any other technology than a smartphone. If you want to collect $400, maybe you can afford more complex technology to make the pricing more precise for the different users. So there's all these questions that seems maybe irrelevant, but depending on those decisions that are usually made at the policy level, the type of technology, the way you have to design a RUC system will really depend, will need to be adjusted. So just I'm going to take 2-3 seconds before moving to the next challenge. So the next challenge is about the emerging technology. So I kind of represent all these technologies that already have been used in RUC programs, but you know, the landscape of technology is always changing. So how do we take into consideration emerging technology? And I'm just going to go very quickly, but there are new technology that we have been talking about a lot, and that influence the road user charging industry moving forward. So one of them is blockchain. Blockchain, as discussing with many people, could be a solution for road user charging financial clearing. So this idea that you have multiple, you have an open architecture with multiple vendors, multiple government entities. How do you streamline those exchanges? So blockchain has been a good technology to manage peer-to-peer and manage complex ecosystem, sometimes with hundreds of millions of stakeholders. So it sounds like a good technology. At the same time, and that's my personal comment, it could be overkill, in my opinion, just because in the blockchain, you assume that the people in the ecosystem, the stakeholders of the ecosystem, do not trust each other, and they don't necessarily know who each other is, and so that's why you need a complex system to ensure the reliability of the different transactions. When in the RUC world, account managers and government entities know each other, and so maybe it's not necessary to bring the financial clearing to that level. But again, I know some people have other opinion, but it's something that we will have to test and see how it works in the near future. Then there's autonomous vehicles. That's a technology that we have heard for years that this is coming next year. So I don't know. It seems like they're making progress, but I don't know when we will have a huge amount of those vehicles on the road yet. But so some of the research have already explored how that will impact the road user charging moving forward. And the conclusion that I got from those studies is there's no technological challenge, because basically an autonomous vehicle is a connected vehicle by essence. So they all have the embedded telematic or can be added aftermarket telematics if needed. So nothing there. What is more interesting and challenging is the policy. So how are we going to charge those vehicles compared to regular vehicles? Are we going to say they're equal, or do we think that autonomous vehicles should pay more or less, or have different rules? So that's going to be the interesting part. The electric EVs, the electric vehicles, this is maybe one of the main reason why we need to move towards road charging. As Maureen has shown, that transition generates some side effects, which are loss of revenue for managing the road. So it's very important to solve that issue if you really want to enhance EVs. And it's counterintuitive. So why an approach that charge EVs kind of favor the deployment of EVs? You know, sometimes it's difficult to explain that to people, but the reality is if there are a lot of EVs, but there's no money to maintain roads, then, you know, EVs become useless because roads won't be easy to drive on. So I think they're tied to one another, and it requires some education to show that actually this is two things that go into the same directions, And finally, computer vision. So a lot of innovation has been seen in that. So how can we detect license plate, but other elements from images? And I think, again, this is going to be a very important part of how do we do enforcement, try to do an enforcement that's as slighted and as cheap as possible to be able to potentially support very large road user charging programs statewide, nationwide, with very limited roadside equipment, or at least at a very minimal cost. So that's the last challenge that I want to talk about. So you have seen the perspective of Oregon and how they have gone, you know, how they have gone about these issues since the beginning. What's interesting so far is that not every location, every state has the same approach. And so without going into too much detail, what we can see is in the way each state is exploring RUC, there are some differences. And so I'm just talking about 4 pioneers across the nation on roads charging here. So one is the Eastern Transportation Coalition. And so in their thinking about RUC, they went directly multi-state, and they also made a big focus on truck as well as light vehicle. Oregon, I don't think we need to talk too much about it. So they were the first to generate revenue from a program, the first to use an open architecture, and the first to talk about a mandatory program that hopefully will be enacted very soon. The Washington State road charging program was also quite innovating in different ways. Like they were the first to test public-private road differentiation. And they also made early on a lot of study about user sentiment, especially taking into consideration different demographics and trying to understand how acceptable would be RUC among them, and trying to understand the different sensitivities of like rural versus urban and that kind of thing. And then California, that took also a different path, because they tried fairly early on different concept like pay at the pump or ride sharing, trying to understand RUC not maybe as a monolithic system that will work with all vehicles, but having RUC as working differently for different types of segments of vehicle. And they were also the first one to try OEM telematics, I think back in 2016 or 17. So anyway, the good thing is, because not every agency is trying RUC the same way, it increased the amount of learning that we can get, and hopefully that can drive more interest from more states leveraging all these different work that's been done by all these different agencies across the nation. So I think I'm going to end there, and I will be more than happy to answer any question related to my presentation.
Okay, thank you so much, Frederic. Before we do that, let's go ahead and do a couple things. Let's just, if you want to go ahead and end your screen share, that'd be great. And let me just make sure. Give me 1 second. And Maureen, if you'd like to pop back on, that would be awesome. So thank you both. So much information. I feel like this is such a great ongoing conversation. There's just so much to be learned. And I know that we had a couple questions. So I see, Maureen, you answered a question, just but because I want to make sure that we have it for recording purposes, that anybody who's watching can go ahead and hear that answer. I will read the question. Would you prefer me to read your answer, or would you like to live answer? Sorry, you're on mute.
Of course I am. Go ahead and read the answer too.
Okay, perfect. So the first question we have is, with geofencing and other location information and exact miles driven, how is privacy addressed? And so the answer Maureen has provided is, our state law includes several provisions to protect privacy. First, the account manager can only maintain the data for 30 days after account settlement, absent permission from the vehicle owner to maintain it longer. Second, law enforcement can only get the data if a warrant has been issued. Third, the state gets anonymized and aggregated data only. These provisions were negotiated with the ACLU and were included in Senate Bill 810 in 2013. So thank you for providing that, Maureen. Did you want to expand on that at all?
Not unless there are follow-up questions.
Okay, I see a follow-up question. For gas-based vehicles, the fuel tax is built in. Why not just include the tax in EV charging at home and at public infrastructure?
The data is not available. So when someone is charging an EV at home, we don't know that that's what is occurring. They could have other devices being charged. So there isn't a metering way to get the data. It is needed to actually apply a reduced charge.
Okay, that makes sense.
So to add on this, so so there's been a lot of research about this done by the energy companies. So they have started installing the same OBD2 devices to tracking charging from the car. Because the problem that they were facing is that all vehicles were charging at the same time, and that would have impact on the network. So the answer is, as Maureen said, when you plug something, there's no way to get the information on what exactly are you using the electricity for. So you do need another reporting technology anyway to be able to track when it's using a vehicle. So at the end, it doesn't really solve the issue if you have to plug an OBD2 device or if you have to work with the OEMs to get that data. I think in addition to that, there are like here we're talking about like the fuel tax is a proxy for usage of the road. So you basically take the assumption that if you use fuel, you're going to drive on roads. And so if you charge the tax on fuel, it's kind of the same thing that charging for the usage of the road. And with charging a tax on electricity, it's slightly the same thing. Is like you assume that the car will drive and that it will use a certain amount of that electricity to drive on road. So it's also a proxy. The advantage of like RUC in itself is like you have a direct connection between the usage of the road and how much you pay for it. And so I think that's a very powerful message. So obviously there are some technical challenges to be able to do that, but I think it's the most fair way to charge for usage.
Okay, thank you, Frederic. I see another question. Could there be a SW code for charging?
A software code?
Yes.
Arguably, yes, but who's gonna standardize that? Is there a whole bunch of people that wanna approach SAE about developing a code for that? I don't see it, honestly. One of the things that we need is mileage, so you could have a code for kilowatt hours used or kilowatts used or whatever else, but how do you get that data, the mileage data from the vehicle? It seems very complicated to me.
Any thoughts
I
on
don't
that?
want to be proven wrong, you know?
Yeah, you're right. It does seem fairly complex, but this is your area of expertise, the two of you. So what do you think about that, Frederic?
So sorry for my ignorance, but I don't know what SW code is. So
Steve, are you meaning software? If you could just, I guess, type in the questions by SW that you do mean software, if you're still on the line. Software code. So he means, could there be a software code for charging? And I believe that was to differentiate between what is charging at your house, let's say, from the previous question, I'm thinking.
So I don't think I have particular expertise to answer that question, but I'm just going to use a very simple argument of saying, again, this is an information that's very important for the energy companies already for a long time, and they've been ready to pay hundreds of dollars to get that information out of vehicle using OBD2 devices that they have to plug into the vehicle. So if there was a simple way, my assumption is that they would have done already, not for RUC, but for the energy companies. So again, maybe an expert will have more information, but that would be my initial answer.
Okay. Are there any other questions? Okay, I think that might be it. I guess a couple things. Oh, the Partiv has a comment. Just says, yes, it's complicated if user is off grid. That's his comment. Thank you for that comment. So both of you, Maureen and Frederic, you are part of our RUC initiatives meeting that meets once a month. I believe it's the first Wednesday of the month. So love for anyone who's interested. If you guys are interested in joining any of our working groups, go ahead and send me an email. My email is bcantlow@omniair.org. That's B as in boy, C as in cat, A as in apple, N as in Nancy, T as in Tom, L as in Larry, O as in open @omniair.org. If you can't remember any of that, it's on our website. We have a link for you guys to go ahead and sign up for working groups. And so all that's detailed, but if you have questions, feel free to send me a message. Anything comes up that you didn't think of today, feel free to go ahead and send me that message as well, and I will get that over to Frederic and Maureen, or we can get that answered for you at our next meeting. Now, we do have one more webinar this week. We have our parade of test stations. That's going to be tomorrow, the 27th. That's Tuesday, 12:30 p.m. Eastern time. We hope to see you there. This presentation has been recorded and will be on our YouTube. Those of you who attended will automatically receive that link. Anybody who missed it will automatically receive the link. And then you'll also see it on our next webinar. Fred